Hi guys, my name is Piyush and today I'm going to show you how to read the isdn q931 debugs. Okay, so before we start, let me show you how how the call flow would look like. So for example, in this picture, I am showing you a call flow between Telco and a Cisco gateway. So in this call flow example, you can see that it's an incoming call from Telco to the Cisco gateway. And in the debugs, when you run the q931 debugs, you would actually see all these messages being exchanged. So let me brief you first about these call messages. So you can see here the first message is setup message. What this means is the telco is initiating a call and requesting for a call setup. Once the Cisco gateway receives this call setup, it would reply back with message called call proceeding. Basically, it means I'm trying to proceed with this call. The next message can be progress or alerting. That would mean that the called phone is actually ringing. So once the called phone answer the call, the gateway would send a connect message to the telco. And telco would acknowledge this message with connect acknowledgement. So at this point of time, the call has been answered and the audio is established. So this green line, you can see that right after connect acknowledge, the call established, and that's where the audio is going on. Once the call is hung up, either from the Cisco gateway side or the caller side, in this case telco, a disconnect message would come, and the other side, in this case the Cisco gateway, it would reply back with the release call message, and the telco in this case reply back with the release complete, and the B channel would be free at this point of time to take another call. Okay, so this is a brief overview how the ISDN messages would look like. So let me take you to the debug. So what I did, I went ahead and collected some debugs from my lab, and in my lab, okay, let me first of all increase the font size. So, okay, I think this should be pretty much easily readable, right? So in this case, what I did, I used this call, for example. There is a PSTN. It has a PLI connectivity to a Cisco gateway, and this Cisco gateway connects with call manager using S323 protocol, and the phone is registered on this Cisco call manager. I logged into this gateway and ran debug isdn931 and made a test call. It was an incoming call from PSTN to this phone. You can see in this example, the gateway is receiving a setup message. So this is important. From here you can tell the direction of the message. If in this case it is RX. RX means receiving, and the gateway is receiving a setup message. In this setup message, you can see a couple of important things. The first thing would be the channel number, and this channel number is 1. Channel number 1 means it's using the B channel number 1. Okay. And the second important thing is the calling party number and the called party number. So the calling party number is 3583, which is on the PSTN side. The called party number is 7729, which is this phone. Okay. What is the other important thing? And how would you track this call throughout the debugs? So what you do is you use this call reference. This is important. Okay. And what you can do is you can take the last 3 digits and you can track this call just by using the last 3 digits. And this first digit actually tells you the direction. Okay, so 0 means incoming message to the gateway. Okay, and we know that. Okay, and the other things you can see in this setup message is it's using 3.1 kilohertz audio signal, and the audio rate is 64 kilobits per second, which is normally G711 codec, right? You can see that calling name is enabled, but in this case, I believe there was no calling name. Telco was not sending any calling name. The plan type is ISDN. The type is national, so it's a national call or a national caller ID. So once this gateway received this setup message, it would reply back to telco with call proceeding. So here you can see this. It's a TX, right? This was RX, this is TX. TX means sending. It is sending call proceeding message. And you can see that the last 3 digits are the same, but the first digit has changed. It's 8, right? So 8 means it's in the sending direction or transmitting direction. Okay? So let me highlight this. So anywhere you see the 0x8, that means it's sending. Okay? And the next message is alerting. So basically the telco is, not the telco, but the gateway is sending alerting message back to the telco. So one of the important things here is, you see this progress indicator, in-band info or appropriate now available. That means this gateway is sending the ring back, and the other side, the calling side, can hear this ring back. Okay, and the ring back is available in band. And basically you can tell the same thing from here as well. So this code 88, it's basically in band. The next thing is the telco is sending facility message. Okay, and this facility message, you can see that it's basically sending name. Or in this case, in my lab, I set it to Cisco systems. Okay, so the telco did not send the calling name in setup, but instead it sent a facility message, and it's in the Cisco systems. Okay. Now look at the other messages. So right now the call is ringing, the phone is ringing, and we are waiting for the call to answer. You can look at the timestamp as well. So this is from April 19, 23/01/18. This timestamp is in GMT. And you can see that after 4 seconds of ring, right, the call was, in fact, more than 4 seconds. Approximately 20 seconds, 21 seconds, the call was answered, right? And that's when the gateway would send a connect message back to the telco, right? And you can tell this direction from this 0x8 as well. And because the last 3 digits are same, 07D, so I know that this connect message is actually for these corresponding messages for the setup alerting, right? So once this call is connected, the telco sends back connect acknowledgement, right? So at this point of time, the call has been answered, it is connected, and the audio will work here, right? So audio is established. Now, the calling and the call party users will communicate, talk, and after when the call is hung, the respective side would send the disconnect message. In this case, the Cisco gateway is receiving disconnect. What this means is the telco basically disconnected the call, the telco side, right? And you can see this 0x. It means it's in the receiving direction. And one of the important thing here is the calls. You see this calls? It says normal call clearing. What this means is there was no issue with this call. It was hung up normally. Okay, and you can tell the same thing from this code. So basically, this normal call clearing is actually code A90. All right. Once the call is disconnected, the telco would send the release message, and the gateway would send the release message, and the telco would respond back with the release complete. And you can see here in this output, it was 4 seconds long call, right? This is the call lane number 3583, right? So it tells you that disconnected from 3583, right? And this is the PRI detail for this call, right? 000:0. Channel number was 1, right? So yeah, so this is the basic ISDN message call flow. And if you understand this, you can easily troubleshoot any issue with telco. You can tell which side disconnected the call, which side had the issue, or if the call was cleared normally or not. Okay, so this is really useful debug. Anytime you have issues with Q93 with PRI Q931, you are going to run this debug. Okay, you can. It's a very easy and not CPU intensive debug, so you can run it literally any time on the gateway and you won't crash it. All right, so yeah, I think that's it for today, and I would end this session now. If you like this video, please do subscribe to my channel and like this video and share with your friends. If you have any requests, any specific protocol like SIP, MVCP that you want to run, please share that in the comment section, and I will record it and share it with you guys. Thank you so much. Have a good day.